Hello everyone, today our lesson is about basic concept and application of probability. The lesson includes basic concept of probability, types of probability, and its applications. Let's start with the first part, basic concept of probability. If you have a package full of cats, such as this graph, only cats in it, then you catch one from this package without looking. What will you catch? A cat or a rabbit? Definitely catch a cat, right? Because there are no rabbits in this package. So you catch a rabbit from this package is impossible. Therefore, the likelihood of catching a cat is 100%. We can also say the probability of this is equal to 1. And in others, the likelihood of catching a rabbit is equal to 0, and the probability of it is equal to 0. When the probability of events happening is equal to 1, it calls certain events. Oppositely, when the probability equal to 0, we said this is called impossible event. However, if you have a package full of cats and rabbits, both in it, and then when you catch one from this package, what will you catch? So the probability of catching a cat from this kind of package is between 0 and 1, because you are not sure you definitely can catch a cat from this package. It is possible to catch a rabbit. So this kind of event with probability between 0 and 1, this is called random event. So from these three kind of events, we know that the probability is the numerical description of how likely they are to occur, and it is the number between 0 and 1. When the probability is close to 1, how about its number of occurrences? It becomes more or less? It becomes more. So when the probability close to 1, this event is more likely to occur. And otherwise, when the probability close to 0, the number of occurs become less, and it's hard to happen. This is the basic information that probability can show us. Let's see this coin game. When you flip a coin on the table, you can get head or tail. We ignore some special cases such as the coin stand on the table, so only head and tails you can get. What's the probability of each side? Each side probability is the same, so totally it has two cases. For any probability of each side is equal to 1 over 2. For another game, we throw a fire dice. We can get 6 different numbers upward. 1, 2, 3, 4, 5, 6. So the probability of each side is equal to 1 over 6, because totally it has 6 cases, and each of these cases is equally likely to occur. So from these two games, do you find any patterns in denominator? For coin game is equal to 2, and for dice is equal to 6. Any patterns? So if an event has a total of n possible cases to occur, then the probability of each cases occurring is equal to 1 over n, which means the denominator is equal to n possible cases. Such as flip a coin, it has 2 possible cases, then the denominator is equal to 2 and probability is 1 over 2. And the other one, throw a dice, it has 6 possible cases, so the denominator is equal to 6, and the probability of each side is equal to 1 over 6. Let's think about what's the probability of getting an even number of dice. The even number of a dice is 2, 4, 6. This is called favorable outcomes, which means an event that has produced the received result or expected event. And the total possible outcomes is 1, 2, 3, 4, 5, 6. We also can call it a simple space. So how to calculate the probability? The probability of even number is equal to the favorable outcome 2, 4, 6 divided by totally possible outcomes 1, 2, 3, 4, 5, 6, which is 3 over 6. It is equal to 50%. So we can see the probability of getting an even number of dice is equal to 50%. So from this question, we can know the probability formula is equal to number of favorable outcomes divided by the total number of possible outcomes. So this is the basic concept of probability.
In this part, we will divide into the world of probability and explore 3 different types: classical probability, empirical probability, and subjective probability. The first type is classical probability. This is a typical example of classical probability. Firstly, all classical probability is based on the assumption all outcomes are equally likely. Like this example, we can only take out one ball at a time, so the probability of any ball in there is equal to 1 out of 8. Next, we can use this formula to calculate the probability of drawing a red ball. The probability of a classical event is equal to number of favorable outcomes divided by total number of possible outcomes. So, in this example, we can know that the event is drawing a red ball. So, I will give you 5 seconds to calculate this result. Great. The result is 3 out of 8 because the number of favorable outcomes in this example is equal to number of red balls, and the total number of possible outcomes is equal to total number of balls. So the result is equal to 3 out of 8. The second type is empirical probability. Empirical probability is based on observed outcome in a sample or experience. Like this example, we know that we already filled it a fair coin 10 times and it landed heads 6 times. So, how can we calculate the probability of getting heads? Sure, we also have a formula to calculate the probability. The formula of empirical probability is equal to number of times event E occurs divided by total number of trials. Okay, I give you 5 seconds to calculate this result. Great. The result is equal to 3 out of 5 because the event in this example is getting heads. So the number of times event occurs is equal to 6, and the total number of trials is equal to 10. So the result is equal to 6 out of 10, equal to 3 out of 5. The final type is subjective probability. It is very easy to learn. Just like its name, subjective probability is based on personal judgment, experience, or belief. It does not rely on data or experience. Like this example, your subjective probability for rain is 70%, thus the result is 70% is equal to 0.7. This is based on your judgment or experience. Finally, we use a very simple example to learn the step of solving this problem. Imagine you have a fair six-sided die which number 1 through 6 on each face. If you were to roll this die, that is the probability of rolling a specific number, say a 4. I give you 6 seconds to think what should we do at first. Sure, this first step we should define the event and sample space. In this example, we can learn that the event is rolling a specific number, for example, rolling a 4, and the sample space in this example is all possible outcomes of the die, which are 1, 2, 3, 4, 5, 6. The second step is to judge the type of this probability. Since each phase has an equal chance of appearing, the probability of each number is 1 out of 6. So we can use the formula of classical probability. It's easy to get. The result is equal to 1 out of 6. Because the event in this example is rolling as, say, a 4, so we can learn that the number of times 4 appears is equal to 1, and total possible outcome is equal to 6. So the result of this equation is equal to 1 out of 6. Okay, our course ends here. Have you learned it? If you have any questions about this, welcome to contact me. Thanks for listening.